My name is Andres Reynaut. I'm an engineer at Marmoset, and today I'm going to be doing a walkthrough of our image-based lighting tools and shaders for Unity called Marmoset Skyshop. When you first import Skyshop into your project, it's going to create two folders. You see a Gizmos folder and a Marmoset folder. The Gizmos folder contains some GUI art and needs to be left in the root directory of your project. And the Marmoset folder contains everything else, and this can be moved anywhere inside your project. The Marmoset folder has readmes and documentation. It has a zip file full of examples and sample skies and scenes that you can play with, or feel free to delete this from your project if you don't want it. It comes with a bunch of shaders and the Skyshop editor scripts. The documentation folder contains a bunch of text files, and these are great reference for how our HDR format works, or what bitmap gloss does, or just general use reference for Skyshop itself. These are great, and you can read these right in the inspector. So let's get started with the tutorial. I've created a Skyshop window, and you can attach it anywhere to your GUI. It has one input panorama and 3 output cube maps that it generates from it. So what I've done is I have imported a sky I found on the internet, austria.hdr. This is an HDR file. We also support PFM and PBM files. If you drag these into your project, Unity will not know how to read them or what to do with them, but our scripts generate an RGBM encoded PNG file of them. The PNG file will be generated with the same name and right next to the HDR file. And it will look a little wonky. It's going to be bright orange. It's because in the alpha channel is where all the high dynamic range data is kept at. So let's take a look at this file. We don't want it to be compressed. This file will not end up in your project. It's purely for generating other content. So we don't need it to be compressed. We can have it at full resolution. Drag it into the input panorama. And you'll notice that this file is in latitude-longitude format. We also accept horizontal cross files, which looks something like this. And you can also drag existing cube maps. Any Unity cube map asset will also get expanded here. So in this little preview, you can see that it's no longer orange. The data has been interpreted as HDR. This little checkbox lets you toggle that. If you disable this, the image is considered to be a low dynamic range or LDR image, and your cube maps will be generated from this orange and blue setup. So let's leave it as HDR. We can also toggle how the panorama is previewed. This is going to take a second as it recomputes it. We can toggle how the preview is laid out. This doesn't change the data at all, just for convenience. So in latitude, longitude format, it looks like this. Now, to generate cube maps from it, we need to create new cube map assets. And there's a handy button next to each output that will spit out cube map assets right next to the input in your project. The cube maps will be generated with some reasonable resolution. So the skybox is going to be 512 per face, not bitmapped. The diffuse is going to be blurry, so that can be 256 per face, and same for the specular. And finally, we select a quality, probably low for now, so that we can preview it real quick, and we hit compute. Okay, now you can see Unity has filled in the cube maps we created slots for. You can also drag existing cube maps into these slots, and the preview will update, and it will overwrite the data stored in there. For now, let's leave this alone. This is all we need for image-based lighting in our scene. You can now add a light object to your scene by either going through the Game Object Create menu or simply clicking Add to Scene. And we will see now if we turn on the background for the image, for the scene, you'll notice the skybox is already rendering, but the lighting is not affecting the camera. That's because the Unity's default shaders are not affected by image-based lighting, and you need to use custom Marmoset materials for it. Okay, now let's set up some materials for our camera. So we need to change the shader. In the shader drop-down for the materials, you can go to the Marmoset category, and you'll see a whole slew of shaders that are very similar to how Unity shaders are set up. You've got bump, diffuse, and specular without normal mapping, self-illumination for glow maps, a whole bunch of mobile shaders, and transparency with alpha cutout, and even a simple glass shader. We are interested in bump specular for now. So let's put all our camera textures in the right spots: diffuse, specular, and normal. You'll see that the texture channels are pretty straightforward. Diffuse RGB and alpha is the transparency. Specular RGB, so the specular map is a colored specular map, and then the alpha channel contains the gloss or the shininess of the surface, and then tangent space normal maps. You'll also notice controls for specular intensity. This is a multiplier on the specular reflection if you really want to boost the specular highlights on your model. There's also specular sharpness, which goes from mirrored reflection to very dull metal. And there is Fresnel strength, which is a Fresnel fall off on the specular reflection. So if you want your object to only reflect along the grazing angles, this is what you'd use. Also notice here there's a default Unity light on right now. Click this little button and turn the default light off, and now it's solely lit by the sky. We also want to make sure that our textures are high quality, so let's take a look at all these textures and make sure that the format is not compressed and as big as it can be. Turn on anisotropy and all the bells and whistles. And it's looking much better. There we go. And you start to see there are little details in the gloss, like thumbprints and scratches and grooves in the back of the camera. This is all from the gloss map. It's kind of important for high quality results. And let's set up the lens as well. The lens should be Marmoset, and we're going to use a simple glass shader. We can talk about the difference between regular transparency and the glass shader in a bit. We want to make our glass mostly transparent too. So now you can see the aperture and everything inside the lens. The diffuse and specular textures also have colors to multiply them. So if we want our lens to kind of have a two-tone effect, we can make the diffuse red and the specular kind of teal. Get that lens coating effect going. Okay. Now, if you notice, if you select the sky, it has a custom inspector, and with a lot of the same UI from Skyshop, you can preview the skybox and a diffuse and specular output in the same way. It also has added controls for toggling the skybox on and off, some color space, and then intensity sliders. So these intensity sliders affect how much light the sky is adding into the scene. So if we wanted to add a lot of light or a little bit of light to the scene, we can control it here. We can control them separately, so we can just say the skybox needs to be brighter, but the lighting stays the same. Leave these alone for a while. And there is a camera exposure slider as well. And this differs from the intensity subtly, but we can talk about that later once we have dynamic lights in the scene as well. You'll also notice that the sky can be rotated, and when you rotate the sky object's transform, everything rotates with it, including the lighting and the skybox background. And this is very handy, especially if you're previewing a model and you want to get a feel for how lighting affects your model from all angles. The setting can also be scripted for nice turntables where the lighting is changing subtly. Now let's add a dynamic light into the scene as well. Go to Create, and Directional Light to represent the sun. You can see the directional light adds on top of whatever Skyshop does. Just fine. We can even make it cast shadows. And now we want to line that light up with the sun as it is coming from the sky. So for that, Skyshop includes a handy little tool. Here you can see, if you click the little asterisk, it will overlay any directional lights in your scene on the panorama, and it will line its rotation up with the orientation of the panorama. So we can use the rotation of the light to kind of line it up where the sun is more or less on the image. And it's not too important to be accurate as long as it's sort of coming from the right general direction. And now it looks like the sky is casting shadows. And the last thing is, now if you rotate the sky, it's obviously going to be wrong. The light is no longer coming from the sun. So we want to leave the sky at 0 and parent the directional light to the sky itself, like so. Now I can rotate the sky, and the shadows will follow. So let's make this a nice sun yellow. You can also use the little color picker to pick colors from the sky itself. We'll try to match the tone and the intensity from the HDR sky. So now we can adjust the intensity of the sun relative to the intensity of the sky to try to get a feel for how much ambient light is in the scene versus how much the direct light is contributing. And that's more or less a user preference. And we can also affect the camera exposure directly. And so here's the difference between the camera exposure and the sky intensity. The camera exposure affects all lights and glow maps and self-illuminating surfaces as well. Turn the camera down, nothing is lit. Whereas the sky intensity only affects how much ambient light is coming from the sky. And now let's talk about the difference between regular transparency and the simple glass shader. You'll notice with the simple glass shader, we have a nice bright highlight, even with a low reflection value on the material. If we change this to normal transparency or alpha blended transparency, the diffuse color as well as the specular reflection get affected by the alpha value. So if we affect the opacity, you'll notice that the highlight goes away as well. What we want is a system where the diffuse component of the lens material is alpha blended, but the specular highlight is added on top of that, so it remains bright even at low opacity. And this means that effectively the transparency value of the material equates to the smokiness of the glass and the opacity of the glass itself, rather than the reflection properties of the surface of the glass. Going back to Skyshop for a moment, there are a bunch of advanced options. There's all the basic ones in this little rollout. And here you'll see settings for the computation itself. The convolution size determines the resolution at which the computation occurs. And this is directly controlled by the quality up above in the basic settings. These are all powers of 2. High convolution sizes will increase the computation time exponentially, so a high value here can make your compute take a long time. We can leave it for medium for now. There are also options to disable building the specular MIP chain. If this is disabled, it's going to not build the specular cube map with different gloss levels at each MIP map level. So if we disable it and just hit compute, it's going to compute a lot faster because it's doing 1/8 of the work for the specular output. But it's also not going to have any varying gloss information, so our gloss maps should disappear on the camera. This can also be a useful preview if you don't want to compute all the bitmap levels at once. You can also, once bitmap chains are disabled, you can specify what one specular exponent is saved to your specular map. So if we make this something low, like 32, we should get a much blurrier specular map. Here we go. This setting can also be used to generate blurry backgrounds. So for instance, if we wanted to take a skybox and make it look out of focus, we could just take this blurry specular map that we created and assign it to the skybox itself, and all of a sudden, an out of focus sky. The resolution at which the cubemap outputs are saved is dependent on, or computed is dependent on how the cubemaps are configured to begin with. So for instance, if the specular map was set to be 32 by 32 by 6, once we compute, it's going to compute a very low res specular output. Similarly, if you want high quality backgrounds for the skybox, you could set the face size to be much higher, and Skyshop will compute for that output. .32 per face is very low, so you can start to see quality problems in the output. So let's put it back up to 256. Now, every time you change settings here, the settings don't translate very well with RGBM data. For instance, here you see all sorts of banding. And that is because when Unity goes from a 32 face size to 256, it's doing filtering and blending of its own to upscale the image. But this breaks the RGBM data where the alpha channel is important too. And so when you want to change the resolutions, you really do want to recompute the skybox every time. Similarly, you don't want to change the linear settings. All the RGBM textures are kept in sRGB space. This helps with the dynamic range of the RGBM itself. That's part of the encoding. So leave all RGBM cubemaps to be in nonlinear space textures. So we have our blurry cubemap. Let's assign the skybox back to be the skybox. And lastly, you don't need to compute all three of these outputs at the same time. If you are only concerned with a specular output, then you can clear these two outputs, and it will only recompute specular. So let's recompute our mid-map chain as it was. You can also toggle whether or not the highest MIP level is mirrored reflection or another slightly sharper but still blurry reflection. Also kind of useful. So let's get it back to proper gloss maps, and we'll leave the highest alone. Here you'll see a list of the specular exponents that are used for the various MIP levels, 256, 128, etc. If you want to find these cube maps again, you can obviously drag them from your project, or you can click the Find button, and it will use the name of the input panorama, the input image, and search for sky and diff cube maps in the same folder. It's very useful when you're setting up the scene. You can also, if you have a skybox in the scene already, and say you switch to a different scene entirely, you can click Edit Active, and it will pull all the skies that are active in the sky into the Skyshop editor. And one last bit about color space. Skyshop works best in linear gamma-corrected color space. And if you're not familiar with that, the way you change it is in the File, Build Settings dialog. There we go. If you click on Player Settings, you'll get a bunch of settings for the output of the application. And one of them, one of the important ones in the Other Settings rollout, is color space. We want to be rendering in linear color space. The details of this I'm not going to go into. It's a complicated subject, but we want to enable color correction, and this ensures that we are rendering all of our light in the correct color space. Now you'll notice that if you switch to linear color space, everything goes wonky. And this is because the data needs to be converted to be used in linear space. In the Skyshop inspector, this is done automatically. And that's what this little checkbox is for, auto detect color space. This checkbox, the linear space checkbox, has to match your project settings for color space. So without it, it'll be either too bright or too dark. And with it matching the project, it will look normal. And then auto detect color space will detect the project settings, but only after you've selected your sky object. And no data is lost ever. It's just something that needs to be kept in mind as you're changing project settings. So now you'll notice that the lighting changed subtly. To readjust, because now lighting is applied to the surfaces in linear color space and done kind of physically accurately and correctly. And after much material tweaking, we have a pretty nice camera going. I've also repeated the process of convolving another sky, this time of a courtyard scene, and I've added it to the scene. So now there are two sky objects in my scene, and if I select either one of them, the preview automatically then change all the lighting. Now in simulation mode, when you press play, it will pick the first active sky it finds. So that will be the mountainside still until we deactivate one of these skies, like so. And that's how you would script changing skies also, as you would deactivate all but one sky in the scene, and then all of a sudden the right one will be playing. And lastly, we've included a handy little script in the Marmoset Skyshop scripts folder. This is the sky script. This is where the sky object script lives. And then right next to it is a logo script that you can drag onto your camera. So now, if we press play, a little rendered with Marmoset Skyshop logo shows up. Completely optional, but if you are a proud user of Skyshop and you want to help spread the word, we would appreciate it. You can also change out the texture to anything you want. So if you look at the script itself, there are offsets. You can make it place in the top right instead of bottom left and change the texture. I hope this has been enlightening and educational. Thanks for watching, and thanks for considering Marmoset Skyshop.